people, right, who make it all happen. Uh, Computing careers hence can make a big difference in the world. If for those of you, so there in the chit chat before this, uh, Megan Smith was pointing out like an amazing person is going to be leading, the computing elements of the Department of Agriculture, right? Imagine the possibilities, just where computing can just transform, many things and bettering our lives. So this workshop, takes us very, very, very small sort of, look at the myriad of possibilities in the world of computing, and especially sort of, focusing on the world of media. Like we are in, Los Angeles, and media plays a huge role in telling stories, about people, to entertain, to educate, to inform, to inspire, to influence, to market, right? Media plays a huge role. And the role of computing in sort of, from the creation to distribution, and the experience of media is so huge, right? So you're going to use that as a platform to introduce the aspects of computing and potential careers. The actual goals of this workshop are twofold, right? One is the technical aspect, like using computational media intelligence, right? Advances in AI and so on in the field of media to introduce sort of, possibilities. The second important part is, professional development and careers in computing, pursuing grads. So you'll hear from people, right, who have actually traveled the path, traveling the path, to see what the possibilities are, in the world of computing. Today we'll have, as I mentioned, two amazing people to join us to kick this off. Our keynote speaker is Megan Smith. Right? Let me say a few words of what her, I can go on and on. So Megan Smith, has done and continues to do amazing things. One of the phenomenal people, right? She's held leadership roles in many places, in industry, Google, Apple, Planet Out, and she was also the third chief technology officer for United States under President Barack Obama, and in fact, the first female CTO in that role, and made a lot of amazing, sort of, initiatives in the computing world. In fact, particularly assuring equitable, responsible aspects of computing, access for all, STEM education, its importance, and that's when we had at USC this great fortune to connect with her, and she got us started in many of these aspects of computational media intelligence, especially with a view toward how can you make inclusive technologies, that is, technologies that work for all, as a means for assuring technologies for inclusion, right? Making creating awareness, creating opportunities for change in the media world. So it's amazing. So that we are here. She's also, a member of the National Academy of Engineering, one of the greatest honors for engineers, and has many other awards, and continues to inspire us. So of course, locally, she's also sort of been gracious and kind of spends time with USC Vitruvius School of Engineering as its one of the counselors. And thank you for that, Megan. So Megan uses the word heroic engineering, and to me, she exemplifies a heroic engineer. She's done, and continues to do great things. So Megan, thanks for staying up late to join us today, and kick this off. Thank you so much. The floor is yours.
Better come off mute if I could get that there. Hi, everybody. It's awesome to be with you guys. My son is a freshman. He's at NYU. And so I understand a little bit of, how this experience is to try to go to college in a little bit of a distance. And his good friend Corey is actually a USC freshman. So, I think he's based still out here in DC where I am. I'm also joined, Susan, are you there? Can you just say hi if you are? Susan Osner?
Yep. Hi, everyone. Susan here.
So Susan is a colleague who I met because we started to do a solution summit through the United Nations, just asking on the internet who already had solutions to really giant problems we have addressing the global goals. And Susan was using basic free technologies to get more people to be able to, she was leading public engagement and was getting more people to be able to bring their voice into UN deliberations. So instead of talking about refugees and migrants, you would ask refugees and migrants to come to the meeting, some people who had lived experience. And I think that this is one of the most important engineering principles, or just humanity principles, is almost like nothing about us without us. And so Susan's really somebody who's been a big champion of that. I've learned much from her. And so she was up, she's in Arizona. So we have a company called Shift 7. If you look at your keyword, shift and 7 mean and. So how about we shift to include everyone? So in our company, the thinking is solution making through inclusion, and to realize that everybody has just really extraordinary skills to bring to bear with things in collaborative ways. So if my computer stops doing its little spinning, I'm going to project some images, because sometimes it's easier to kind of sometimes share some of these images in a way so that we can go more quickly through a lot of different things. So there we are. Okay, you guys seeing? Can you see that?
Yep, perfect.
Okay. All right, cool. So this idea of collective genius, this idea of systems change, and I'm going to go like crazy fast through a lot of different images and ideas, and I don't have to tell you the complete idea, but you can get sort of a blink burst of these ideas. Some of them are very directly, computational, if you want to think of them in terms of really data science related, or others. Some of them are more really maybe a different kind of engineering, or not at all, but you could always think of a data science or a dashboard or some kind of community collaboration tool that might have some signal capability to it that could help. So if you are really focused on this kind of technology, you're going to be able to be part of any of these things that I mentioned in some form. Or you might say, hey, I want to be in this other space. So the first thing I wanted to talk about, because everybody's so busy talking about artificial intelligence, is human intelligence, right? And my favorite story about human intelligence, if you've ever seen the movie Moana, is that capability to sail like that. And it's based on truth. The Polynesian navigators are real. And this is their boat. This is one of the boats that was recreated in the 70s. We have a friend, Penny Martin, who was on this for the sailing. And what's special about this is that, it's a very ancient technology, humanity and sailing all over the world. Most cultures figured out how to do these kinds of things. This particular group of colleagues on the planet figured out how to navigate with no instruments very, very long distances. So when the team recreated the Hokulea, and then they worked with Mao, they actually sailed dead reckon to Tahiti and back from Hawaii with no instruments, just humans and the earth, right? So a few years ago, they left and sailed around the world. So just think for a minute, like imagine a couple people next to you on your Zoom call, like 10 of you, you're out in the middle of the Pacific. Which way do you go? You're on that boat. Isn't that amazing that they could do that? That's amazing. Humanity can do that. And so every time we get all caught up in artificial intelligence, we've got to remember that it's about human intelligence and the greatest capabilities that we have that are important, and maybe we could use technology for good in those ways. These are some of the young navigators. Lahu on the right is now a master navigator. And some of the imagery when they came back to Hawaii, there may be students from Hawaii here. I have never met anyone from Hawaii who doesn't know about the Hokulea. And one of my favorite things from a heroic engineering perspective is in the top right corner. You see the students, and the president of the University of Hawaii with Nainoa and others called a grand challenge and said the Alawai Canal, which is behind Waikiki, is really polluted, and the whole watershed of Honolulu is flowing into this. How do we fix it? And so the elementary, middle school, high school, and I know you guys have a grand challenge engineering project capabilities, whether it's doing that or doing project-based learning, everyone can be part of fixing things. And so these were some of the students who were winning, had genius ideas One of my favorite ones was not even technical. It was just to have a farmer's market there so everybody would come by and see how horrible it was and be motivated to fix it. So just who knows, but that was the middle schoolers. So ignore the sound on But I wanted to show you this. This is a student project. I'm on the board of MIT, so this is done, but this could be you guys, whoever, that we have humans and machines and code and data connected at a level that you could make something cool like that and control and fly. You know, what should we use this stuff for? I did the acquisitions of Google Earth and Google Maps. And one of my favorite things was Lalit, a colleague in India, made a Wikipedia-like capability because so much metadata was not available for like 2/3 of the world. So if you were from Lahore, Pakistan, maybe on this call, or you have friends there, really Google Maps looked like this in the beginning. But there's like a ton of people there. So what they did was you could draw yourself onto it. And in 6 months, the people living there using digital tools and human capabilities and collaborations put themselves on the map. So with President Obama, at the end of administration, we did a frontiers conference. And I just put this up because we talked about these cool frontiers. So you can think about these structures like personal frontiers, like what about personalized learning and the brain and you know, the microbiome in your body, like all this cool stuff that we can learn about. Local frontiers, not just smart cities, but how about wise too? So like a smart wise city and the communities involved. And what about nationally? We looked at AI and national policy. We looked globally at their environment, climate change, energy transition to green energies, and cleaning up the mess. And what about environmental injustice and discrimination that's gone on with the dumping on certain people? Susan and I work very closely with people, Native Americans, who are facing great challenges with uranium dumping and other things. And then interplanetary, which is thinking about a global, you know, the near commercialization of space, and also our journeys on, you know, out of the universe. And it's so important to keep that exploration. One of my favorite moments was a really interesting stereotype comment that someone made, and it relates to our signal processing work that we do on gender bias and race bias that we see in media. This fabulous woman was on stage. She's one of the engineers at Blue Origin, you know, in commercialization of space. And they're in Seattle, and her husband works at Boeing, and she has young children. And her son was adamant, saying to her daughter, no, the girls work on rockets, the boys work on airplanes. So, you know, there's stereotypes all around. And so just interesting things to think about the frontiers we have. On the bottom right, you can see Dennis McDonough, who's now going to run the VA, but he was the President Obama's chief of staff. And what he did was held a kind of a meeting on stage of how he would hold a meeting in the Roosevelt Room in the West Wing to have a policy conversation with all different kinds of people, in this case about AI policy with Dr. Fei-Fei Li and all kinds of experts from our country. It's a really like an open town hall, the way that the best policy is done, and you try to get the most voices in, similar to how Susan was doing things at the UN. But I wanted to turn our attention here because it's really inclusion and all the challenges you guys are Gen Z, you're experiencing and you're knowing about the complexities of our world. And so how do we include everyone? You know, Congress is getting really divided. This is an amazing data animation from Business Insider showing how they stopped voting together. They used to vote together more. And really President Washington tells us that science and literature, not just engineering, not just arts, but all the disciplines together are important to promote. When he spoke to Congress in 1790, knowledge in every country is the surest basis for public happiness. And you know, I had the honor to help start the Malala Fund and this idea of education and learning and capabilities and knowledge and not fake news. So we've got to figure this out. Liberty, according to our founders, is actually related to science and industry. That's the first American penny. So freedom and liberty. But we have weapons of mass destruction. I encourage you guys to watch this TED Talk. Maybe you could get together and have a conversation about Kathy's book. Or the Algorithmic Justice League, face recognition. You know, these phones that we made are really racist. You know, why is it that we have to change the flash for certain color skin and not others? And, you know, that was true with Kodak film. And why don't we just stop doing that? Also, when we make projections about AI, this is an older slide about, but where's Africa? Like, there are talented technologists from Africa, and they could be part of the AI economy. So there's a lot of stuff out there, like Burning Man versus Atari refugee camp. you know, a place found by sadness, a place found by joy, but they're similar size in budgets, but the systems, the hard systems can be unkind. But we can fix that with signal processing. We can make an inclusive future in all these ways. So this is just looking at, like, some people in Chattanooga have the highest speed internet in the Western Hemisphere, Chattanooga, Tennessee, and some people are having to get water. Some people, you know, are in jail, but if you do training, you can have 7% recidivism. You know, there's as many open STEM and tech jobs as people in prison. Like, this is a crazy thing. So how do we think comprehensively about this wonderful agenda that the UN gave us, that Susan was so much part of bringing public voice in? And so we go looking for innovators. And so one of the things I encourage you is scout for really cool stuff that you can do internships and programs on, as much as you might do a hackathon and come up with new ideas. Both are important. In the Amazon, make a fab lab, a makerspace. You guys have a new one at USC, instead of cutting down the trees. And we found an innovator named Ben O'Horace doing that. So there are people around. This was the year before, genius innovators. And one I'll share is Bernice's Ghana Bamboo Bike Company. So they don't have a steel industry. They invented these beautiful bikes. They said it can sequester carbon, and they're just doing beautiful work. And like Tom shoes, every time they sell 10, they give one to a child. And here she is at the UN with a community of networks. So this is another learning. When you're doing invention work or innovation work, get your classmates, get your colleagues, get your professors, and have a network that's helping you. It can do a lot. And there's these networks all around. Here's Boise, Idaho, of tech meetups. Here's Gaza Internet Camp. Here's Afghanistan and Herat, you know, technology teammates everywhere. And this is an image from the tech meetups out of the Google developer groups. We work with Native American innovators at Shift 7 with MIT on solar and agriculture and anti-trafficking, and just incredible work that people are doing. Island innovators, some of them master navigators, but also people working on new kinds of agriculture and solutions for climate. In the United States, we brought together all the tech meetup organizers from all these cities who are creating community for doing heroic engineering and locally, building economic solutions, social solutions, civic tech, and others, and some innovators on other programs. And then we started to realize that one of the biggest challenges, neighbors don't know each other. So most people in the city might not know there was a tech meetup they could go to. So how do you let the employers know they could hire from new ways? And how do you let the mayor know? And how do you welcome people into that? So we started doing this tech jobs tour and went to 25 different cities. This is Cleveland and speed mentoring. And this is 2,000 people in Oakland. And now our tour, we found amazing innovation. So these are young people on the Mississippi River, and someone made a STEM boot camp inside the container box so it could be at the playground. And people were doing fabulous work and also lifting history. So everywhere we went, all over the country, there were innovators and really exciting economic future, from Appalachia to Birmingham to Cheyenne, Wyoming, but just most neighbors didn't know. And so maybe one of the things youth can get involved in is using Signal to share beyond Silicon Valley. There's genius stuff also over here, you know, and we can be involved with that. George Washington Carver did it. You know, some people say, oh, the peanut guy. Well, he's kind of the nitrogen fix the soil guy. He saw the malnutrition and he helped train 10,000 farmers a month and community organized that. So these ways that we work for sprinting and innovating, we can apply them to any topic, including data science. So this is just quickly, I'll share, bringing tech folks, civic tech, into government to work on policy issues, but also better interactive websites and dashboards. We launched analytics.usa.gov. So a secretary of one of the major departments like agriculture or energy could have a dashboard for their users, us, the American citizens. What are we doing on their website, and how could they serve us better with the website, just like maybe somebody from Amazon or Walmart might. You know, just get rid of these terrible government forms and make responsive websites. Opportunity Project is one of the greatest ones. You guys might be able to do some homework projects. There's all kinds of data sets from every single department, not just the ones that were always getting a lot of attention, like the weather or the mapping data. So, you know, getting in there and solving problems for fellow citizens using for education and for Hack the Pay Gap. This is an example of that. And we made a data science cabinet for data scientists to have community, like a community of practice, because we found NASA was really good at it and the State Department, not so good yet. So they could be colleagues and get together and have a rubric about it and learn. We could do an open challenge for the Ebola suits, which happened. And so the new suits are much more friendly and much safer and much better for the people. This is happening all over the world. It's happening in your towns. There's foster care hackathons. There's, this is Grace, she's in 10th grade teaching the police chief how to code. So we did the police data initiative. So think about justice and signals we can have for better justice for everybody. Use of force data, officer involved shootings, all these kinds of data sets that can be more out there. And this particular one was showing the sharing across all these cities. So this idea of young people getting involved in problems, this is a young woman getting environmental testing and a wonderful movie called Inventing Tomorrow. This is our colleagues working on making sure the Grand Canyon is safe. And so hopefully there'll be some movement there. Chief science officers, computer science for all children. What if everybody from kindergarten learned a little bit of data science and coding? Then it wouldn't be like this special thing. It'd be something that we just did. And then we could pursue better, more equally. In LA, the Data Science Federation lets you work on your hometown for your homework. So you guys can get a hold of some of these projects for some of your classes. Just a tiny bit about Shift 7, which is we work together. We're a small team, but we try to co-create. We try to get people to meet each other, and we try to make sure people know about it. This is an image of President Obama with the Science for Kids. And the thing about inclusion is these kids are doing brainstorming and prototyping in kindergarten. And that's normal. So why don't we just do that with everyone for confidence? The last thing I want to mention is a signal around equality in media. This is a graphic from some colleagues at Putting Polygraph.cool, and they're showing men's lines to women's lines in 2000 films. You know, Shri and I got to know each other because of Gina Davis. And what happened is we were both selected to work on some things for the UN, and she shared her insights about women's roles. She could feel this as an actress. But people said, oh no, we fixed that. And she said, well, we have to fix it in children's television especially. And it wasn't true, so she tried to get the data, and she was doing it in a very manual way. And I said, I think we could use computer science. And so we all found each other, and they all began working together. But the last piece is that the truth is it's always been women and men. You know, Ada Lovelace, who invented the idea of algorithms, has cool hair. You know, the people at Bletchley Park, you know, if you haven't seen Imitation Game, you should watch it. I walked into the Oval Office right after Prince William. It was just random that happened. And I said to President Obama, you know, what we're about to do, which was to go do the coding work with the students, is related to Prince William. And he said, how's that? I said, the Duchess of Cambridge's great aunt and grandmother were code breakers at Bletchley Park. And he said, oh, the movie didn't show, but 2/3 of the women, 2/3 of the people there were women. And so the same thing's true. This is the 75th anniversary of the ENIAC programmers, which is the first digital computer in our country. Eckert and Mockley made it, and these were the first programmers in America. Grace Hopper invented coding languages, and the Macintosh team from Apple was much more gender balanced than people let on, and we got to work with them at General Magic. And people from other industrial age times. This is the second industrial age. Jane Addams, she was considered one of the most dangerous people in America. But she invented social work, and she got the Nobel Prize, and you guys have a social work school. They are definitely your colleagues. These are some of the work that they did. They would measure livelihood and who was there and all kinds of stuff. The best ever WISE city. You know, we could do that with them from your teams. You know, whether it's ecology data or justice data, Ida B. Wells and the Red Record, and stopping lynching with data science and journalism, and then pushing hard to get more representation in the Chicago World's Fair. They didn't allow an African-American pavilion. And even CES looks the same 100 years later. So we've got to change it because the people are there. You know, in this document, it lists all the inventors and sculptors and architects and everybody who would have been there. So we're fixing it. So we're fixing it slowly. Katherine Johnson, we know about. Margaret Hamilton, we know about. We know there's Mercury 13 and 7 astronauts. And so I'll end there. I think I had one or two other little things out here. Oh, that there were 4 women in space. So we don't always see that. We usually see 1, including 2 women of color. So let's know that that happens. And I remember when I was your ages, we built solar cars. I built crazy windmills. And I had pulled some of these because I was talking to Gitanjali. And my main thing to you guys, we made hardware for underwater and worked on oil things, which I'd love to work on solar more. And I got to work with this team. on the beginning of smartphones. These are some of our prototypes. So I'm going to end there and just thank you for your interest in this area. We really, really need you badly, you know, for all of this work. And also, I'm not a doctor. I have an honorary doctorate, but I'm just Megan. I didn't do the hard work on PhD yet, so we could collect that. I'm Megan Smith, Ms. Megan Smith, Master of Science, so I'm MS cubed or something.
Thank you. As always, so inspiring, Megan. Thank you so much. I think what a great way to kick this off and inspire, you know, the whole set of students in this workshop. And you know, as I promised, right, like, you know, like I said, like computing reaches everywhere. Megan just gave us a, like, you know, just a flash view of all possibilities, you know, especially, emphasizing equitable computing, you know, computer science for all. And it's so great to have a treat. Susan Elser could join us. You know, she, you know, again, one of the great thinkers and minds, you know, and so particularly her work at the UN has been amazing. So hopefully, you know, during the course of this workshop series, maybe we'll hear from Susan and see the possibilities.
Yeah, that's a good. Hey, Shri, I have one thing which is for students to know. Susan has had many different kinds of jobs. And one of them was early on in rock and roll as a photographer for a lot of bands from those times. And so you never know what jobs you do, you know, sort of working with Indigo Girls and Midnight Oil and did some of the B-52s, Love Shack. I don't know, Susan, if you say that, but I just think you guys should know there's many paths to many different careers. And this tech part of paying attention is really important. So thank you for your interest and enthusiasm in this. And I hope you'll apply it heroically to the things that matter to you.
Yeah. Thank you, Megan. So as I pointed out, I call Megan a heroic engineer. Truly, you know, she built stuff. And thank you, Megan. And so it's a great way to start off our workshop. You know, this will run for the rest of the semester, you know, every day, week. Megan, feel free to stay. I know it's pretty late in DC, but we'll keep you posted. And perhaps, you know, on your next trip to LA, you know, we can get to meet some of these students as well. You know, we all are, you know, really eager to get back to campus. So thank you again.
Be there, everybody, and be in community, because this is a very strange time and we all need each other, and humans are about being connected. And so just, we're linked, not ranked, as Gloria Steinem says.
Yeah,
Like
before we let Megan go, do any of you have any comments or thoughts or questions for Megan?
Anything that comes to mind?
I know we have a packed agenda, but if not, you can always, like, you know, channel your questions to her later on, and also. So, thanks, Megan.
Thank you, people. We're so proud of you guys dealing with Zoom school. So great work. Bye, guys.
Bye.
Good luck, everyone. Thank you.
So we have another amazing speaker. Thank you, Susan. Yeah, amazing speaker today, Dr. Zhu Kim. Dr. Zhu Kim from Google is with us today, and he'll be sort of a mentor for this program. So it's a delight to introduce always, you know, our illustrious alumni, right? So Dr. Kim got his PhD in computer science from our own USC Viterbi School of Engineering a little while ago, and has been you know, his area of expertise is computer vision, you know, making things work. You know, this is even before, you know, deep learning and stuff became, you know, sort of, you know, commonplace. Now they've all carried this. Actually, one of the people, like, you know, involved in bringing, you know, what used to be, you know, more academic questions, small data sets, to real world and things, you know, that are there in devices we use day to day, in phones and, you know, in vehicles and so on. So it's a delight and honor to have Dr. Kim with us. You know, he cares a lot about not only sort of, you know, research and development, but also sort of, you know, sharing that knowledge with particularly young minds and in careers. And so he has graciously agreed to be a mentor for this program this semester. And, you know, thank you so much, Zhu, for joining us. And floor is yours. He's going to, you know, give us the next talk.
Let me share my slide. Good evening, everyone. Wow, what an honor to be here in the same program with Megan. Um, I believe the attendants here also have such great potential to do so many great things like what Megan did. So my talk also has some common theme with what Megan just showed you. But hopefully it'd be helpful if you can also hear from a story from a field engineer like me. So the title of my talk is Do Cool Things That Matter. Uh, in fact, this is a typical Google Outreach talk title for elementary or middle school students. But I just love this title. And actually, this is my challenge to you today. And by the way, if you're wondering about my background image, it is actually our actual office in Venice. And of course, we have many teddy bear researchers in our organization. So yeah, as Professor Narayanan introduced, I did my PhD at USC in computer science in computer vision. And my PhD thesis was about detecting and describing man-made buildings from area images. Then I worked for UC Berkeley, where I did research and development work on intelligent transportation systems and unmanned air vehicle navigation. Then I joined Google about 9 years ago. Later in this talk, I'd like to share a little bit on how I ended up joining Google. But anyway, now I'm a software engineer at Google Research, and I develop visual search infrastructure, which is used by Google's landmark recognition system. I also perform some research on how to efficiently organize a vast amount of data we have for an AI system. So I believe you all know what Google is doing. This is Google's mission: organize the world's information and make it universally accessible and useful. I just want to emphasize that universally here means to everyone. I work for Google Research, and its goal is to advance the state of the art. And Google Research tackles challenges that define the technology of today and tomorrow. Google has lots of cool products. You probably recognize many of them. And all of these cool products contain super sophisticated state-of-the-art technologies. Obviously, one is a state-of-the-art AI technology, like for example, Google Assistant. But you may also get surprised that like some of other products such as Chrome or Gmail are also using state-of-the-art technologies. For example, Gmail uses a sophisticated artificial intelligence algorithm to intelligently filter out all the spam emails, or Chrome recognizes the image contents and reads it to the people who are blind. Let me show you some more examples of Google's state-of-the-art products and research. This is a visual search product called Google Lens, which I also took a part in launching. It is also available. It is available on Android phone and iPhone. So in iPhone, if you use the Google app, then you can actually do the image search using this Google Lens. It uses this product uses many state-of-the-art image understanding technologies. In fact, Google is leading the image recognition research, and Google provides like cool open source tool called TensorFlow, so that you can do like image recognition on device and off device. Another example I want to show is an AR walking navigation. I often get lost when I walk around, not knowing which way is the north or south. And the Google Map, you probably didn't know. I don't know if you already knew, but the Google Map has a walking navigation feature, and then there's like a live view feature. So if you look at it, then it will actually match your camera image with the Google Street View images and tell you which direction you need to go, like on the screen. This is the like first thing you may try when you travel after this COVID situation is over. And there are also many, many related state-of-the-art research efforts within Google Research. Google is also well known for its speech and language understanding technology. I believe many of you have tried Google Translate, which works really amazingly, and a lot of them is based on this state-of-the-art technologies. This is another research area that Google is leading the world, the quantum computing. The quantum computing has only been an area of theoretical research until like recently Google announced that we reached the quantum supremacy, which means that it can now solve the problems that conventional computers would take forever to solve. So very cool. So many cool things like that. And then these are just a few examples. And of course, you can work on the next cool thing when you choose to pursue computer science research. I want to go back to my title, Do Cool Things That Matter. And I want to challenge you to not just do cool things, but to do cool things that matter to you and matter to this world. Not just to make money and have a stable job. You can also do that by pursuing the research, but do something that is meaningful to you and to this world. I'm not only talking about the super philanthropic stuff that Megan shows you, but let me give you some examples. For example, like Google Search and Translate enables people around the world to access information that wouldn't otherwise be available. That's such an empowering experience to many people. Or Google Photos, it enables you to store your precious memories and makes it easy to look up. Or Waymo, in Waymo is Alphabet's self-driving car branch. In Waymo, people are trying hard to develop technologies so that people who cannot drive for various reasons can go anywhere while reducing the tragic traffic accidents. Google also has personalized ads. Some people may think that it's a spooky thing that Google figure out what I'm interested in. I'll actually talk about the privacy issue a little bit later, but in fact, it is a very cool thing and meaningful thing that that we can actually only get the ads that matters to us, and it also helps the business to connect to the right people. Of course, like Google also spends efforts on philanthropic causes as well. Many work Megan shows you is actually done by the Google org, but also we have a product. For example, Google has a Lookout app. You can all install from Google Play Store. I believe Android the iPhone has this app too. But this app helps visually impaired people to read text and product labels. Or Google worked with Apple to develop the COVID exposure notification system software, which notifies you of a potential exposure to COVID while protecting your privacy at the same time. So if you haven't installed it yet, you should install this app. But it's not just what you do, but also how you do matters too. As you've seen in the example of the Google Ads and the COVID notification, privacy is very important. In fact, Google keeps tons of private user data. So keeping them safe and handling it in a way that meets users' expectations is very, very important. So Google has a very strict privacy practice. For example, like every little changes that affects user interaction and data go through a thorough internal privacy review. Google is also trying hard to be environmentally responsible. Google has invested heavily in renewable energy, and now Google is carbon free, which means that we compensated all historical carbon energy usages, and we are investing even more so that your Google searching or YouTube watching don't generate any carbon emissions 24/7. Another efforts I'd like to introduce is fairness and ethics in artificial intelligence. So Megan also showed you, but you may also have heard some of these ethics incident and crisis created by some AI systems. Some people might think that AI is error prone, but it is not. AI is made by human, and it is often trained with biased data. In fact, all data is biased in one way or another, and it is created by biased people, including me, and it is often based on algorithms that is not carefully designed. Bias is just one issue here, but there are many other problems related to AI, including privacy, security, mass surveillance, or filter bubble, to name a few. So therefore, Google is also putting efforts to improve the fairness and ethical aspect of AI. Google started the People Plus AI Research Initiative and also investing on machine learning fairness research. And also, Google provides machine learning platforms such as TensorFlow and Google ML. We also try to make sure that the partners, people using our technologies, are also well aware of these issues. So we have published many educational materials for them. So if you have time, you may also go to some of these sites and take a look at them by yourself. And we also try to make sure that the AI technology universally benefits all people. So we want to try to we want to lower the barrier to the AI. So you can also try the Google's AI Yourself project. Finally, we need more representative developers and researchers within Google. So finding talents from underrepresented groups is one thing, but that's not enough because we just simply don't have the researchers and developers from some minority groups. So we have provided diversity internship program. For example, there's a STEP internship program for freshmen and sophomores. So if you are if you know anyone, or if you are like rising sophomores, actually the application due is over, but for this summer, but take a look at this STEP internship program. And there are like many more outreach programs for K to 12 minority students at Google. And also this exploreCSR program is a part of this larger effort. We definitely need more women, Black, and Latinx researchers in the computer science research field. So hopefully my talk interests you to consider pursuing a research career in computer science. And I want to wrap up with my personal story. So when I was in your age, doing meaningful things wasn't my first priority, making my career decisions. But I fortunately ended up doing computer science and PhD, and I was very fine with that. And one project I ended up doing was this cool drone navigation work. And one of the funded research I was doing was about tracking people from a drone. I have no intention to put down anyone working on similar projects, but this specific project didn't really fit my personal value system. So I really struggled between my job and my value system. So I prayed to God, and God answered my prayer. I was laid off. So there's a long story, but basically I ended up leaving my research field and joining Google as a pure software engineer. I was actually first hired for Google Analytics, and then I started to learn professional coding from the beginning, and then working on projects that are not related to computer vision at all. Then I was thankfully able to work on the Google privacy. So I moved to Google privacy team and worked there as a software engineer also like doing nothing related to computer vision for 2 years. I had like 10 years of professional experience in computer vision, but I ended up teaching it. But somehow I ended up coming back to my old research field, and I now and I now have more solid coding experience because of uh, my experience with Google Analytics and privacy. And also I have this research background. So I am actually working on both research infrastructure development and also doing some research right now. And because of my personal history, I try to be more responsible for what I make. So I mentioned that I'm doing the data curation research, which is organizing a vast amount of data for machine learning. But actually, my focus is on how to organize them in a fair way. How can we do the landmark recognition fairly? So I'm trying to find the answers to the question, like, are we recognizing world's landmark fairly? Like, what is the definition of fairness here? And how do I remove bias from our current system? So those are some of the research area I'm working on right now. I am also a privacy reviewer for Google Photos and machine learning. And I also volunteer for many of the diversity and inclusion projects by Google. And so giving talk today is also a part of my personal efforts to be more responsible. Google is a very nice company, and I personally give credit to the leadership's efforts to be responsible. But it's not going to work unless we have employees who tries to be responsible for what we make, and unless we have workers and users who are trying to make the company more responsible, it's not going to work. And we definitely need more researchers from the underrepresented groups and add more diverse viewpoints to the company. So this is the end of my talk. To summarize, I'm now happy and I'm working on cool things that matter, I believe. And hopefully you can also find your own cool things that matters to you. Thank you. And actually, I probably have a little more time or to take question and answer.
Absolutely. Thank you so much. So inspiring, actually. What a great, talk, to again, to kick this workshop series. I want to underscore, a couple of things that, Zoe shared, like, again, the broad reach of the possibilities of computing, but also it's not, at the end, it connects with people, right? It's it's for people, by people, and that aspect is so important, and, not just in doing cool things, but cool things that matter. It's wonderful. And, the theme of this particular sort of workshop is also sort of in the media intelligence, was inspired by actually developing sort of tools and techniques and methods that are inclusive and also sort of will shine light on inclusion in media. So we thought we'll choose that as a platform to illustrate some of the possibilities while listening to and talking to the stories of people like Dr. Zoo Kim, like Megan Smith, about various aspects of computing, to consider, like, there's like not one pathway, right? Like Megan also said, many pathways of using and creating and designing computing to change lives. I think it's inspiring. Thank you so much, Zoo. So we have time for some questions that I can help moderate with Dr. Kim. So if you have, please unmute yourself.
Hi, I had a question. I was just wondering what like computer science research kind of looked like in a day-to-day basis and what sort of tasks you would do to keep a project going.
Yeah, there are multiple forms of jobs that you can choose when you choose to do research. And like Professor Narayanan, like at university, like which is focused more on the pure kind of research. Google is more like a company. So our research sort of connects to the products, but Google is a bigger enough company so that it doesn't have to be like directly connected to the product. so we have many different kinds of work at Google. So there are some people working really closely on the product. For example, I work with a lot of people from Google Photos, uh, using all the machine learning algorithms to uh, improve your photo experience, like like automatically finding all the relevant photos from your repository of the photos and presenting that to you, like, oh, look at this beautiful memory of your past. That requires a lot of like artificial intelligence technologies. So those are, but it also involves a lot of coding, and so you need to know like coding and also like state of the art research at the same time. But there are some people who are more working on the research part, like whose main focus is to finding out the like state of the art technologies, writing papers, and then like present them, like show the possibility of what Google can do using those technologies, creating like a demo. Well, they also program, like creating demo software, things like that. So coding is also important in that sense. Uh, yeah, but I also work on the infrastructure. I actually uh, write programs that helps people do this kind of research better, like how like storing all the like large scale of data, like videos of millions of like billions of images, and we have to store all of them somewhere. Then those are also day-to-day job.
Thank you. I really appreciated your talk.
Thank you, Rachel. Um, Others have questions for Dr. Zhu. Remember, like, there's both technical and professional development and careers. All those questions are valuable. So ask away. Please, I think Chris has his hands up, right?
Yeah.
Yeah.
When you mentioned about how you got laid off and that was kind of the turning point in your career, where you felt like, this was your start of doing something purposeful. I remember from a few years back, in a guest lecture, I forget who exactly, but he said something like, there's a difference between your job and your work. Like you'll have a lot of different jobs in your entire lifetime, but you'll really only have, one true work, which is like purposeful. And I just wanted to ask you, for a lot of our juniors and then seniors out there who are starting job search, what advice you would have in terms of, like pursuing purpose, not just a title or financial stability, but more so doing something meaningful.
Yes, that's a good question. Yeah, actually, that was and is my thinking, that I uh, don't think that my job has to be like uh, something that would like I'm personally consider myself a philanthropist, and then I want to contribute to this world, but not necessarily through my job. Uh, so when I was a PhD when I was a PhD student. There was this research professor, like who always go home at 5 p.m. like who only works for like 9 to 5. So he was like my role model. Like I want to be like him. And then like the rest of the time, I can do like whatever I want to do to either contribute to my research, like through my volunteer work or through my church or whatever. So that was my goal, and that is still a big part of my life. Uh, and but at the same time, I do not want my work be used for something I don't want to be used. So the people tracking from drone was one example, and also like like when I was doing PhD, it's similar now, but a lot of computer science work was funded by the defense industry, and I'm not saying that defense industry is all bad or anything, but I have been thinking that like they were like overly represented and overly had too much power. So so it's there. I was like, I'm not Noam Chomsky. I cannot like refuse any funded project by defense industry. But at least I wanted to be like, and in fact, a lot of good project like internet came out of defense research, uh, for example. So it's not like evil. So I wanted to. I just wanted to be make sure that I don't uh, get dependent on that. Uh, I don't want to be dependent on that money, and I want to be able to choose what I do. And I believe that just being at USC, just studying at USC, actually you also have you are also very talented, and you can find a job that you can work 9 to 5, and you can actually choose what you want to do, or you can also choose what and you can also not choose what you don't want to do. So that was where I was coming from. So actually, when I was working for Berkeley, my whole family was in Southern California. So I was like actually flying every week for 10 years. So when I got laid off, I wanted to find a job in Southern California, and lot of computer vision related position in Southern California was actually defense related industry. So that's why I decided to leave the computer vision field. At the time, Google didn't. Well, actually there was Google too, but I never thought that I would be able to work for Google. So it's yeah. That's,
Thanks for sharing that, Zoe. I think, so, there's like pathways of, a career and trajectories. And I think, as long as I feel like people have a purpose and, this open mind, wanting to make a difference with what they do, enriching themselves. People talk about growth mindset, and, careers in computing offer this whole range of possibilities because of its interconnected nature with all, pretty much every realm of humanity. And I think that's an exciting, and what do you do and how we do it, it's up to us. I think it's a great point for making that. Any other questions? As we, I know there's a big program. All the mentors are waiting to get going on the next big part of the workshop. Um, if we don't have any further questions, I'll hand it over.
I have like a quick question.
Please.
Hopefully it won't take too long.
Yeah,
So
go for it.
personally, I'm really interested in the application of machine learning in healthcare, and like I've been working on a couple of projects that involve like diagnosing various diagnosing like Kawasaki disease, a disease that affects children by using like images and things. But I was wondering, like, where do you think people need to draw the line, especially in a field like healthcare, between using like an algorithm versus like human intuition? Like, how does one straddle the line of being careful, especially when dealing with something like human lives, and using something that's built on an algorithm versus human intuition, which can also in and of itself be biased?
yeah, that is a very tough problem. That is a very tough question. And so but basically, like in many cases, all of these algorithms are tools to help our decision making. So and now, like, people are hearing that like actually a lot of AI-based decisions are even better than a lot of professional people now. But so that's why like we have to keep studying, and then we have to keep learning how to use all those tools in a better way, and then so that that becomes like our tool, not like something that makes decision for us, but like we want to use that to like help our decision making. But another thing, a lot of times our intuition, so-called intuition, might be coming from, like, they are coming from our experience. So many times they could be biased, or they may not have strong base. So actually using computer algorithm, and so we should not just use computer algorithm, but we should make sure that, like, why the computer algorithm came up with that answer. And then that is actually helpful for us to make sure that we are making a good decision. Does that answer your question?
Yeah. Thank you.
Thanks for that insightful answers on that. That's the whole notion of computational advances, technological advances in general, right? I've always been supporting people do better in whatever dimension of what better is, right? Technology always tries to make human life sort of better and safer, healthier, easier. But at the same time, anything will have unintended consequences or other aspects of it that people might not, the creators may not have even thought about. So constantly thinking about it. So all the various discussions on some of it, which Dr. Kim touched upon on, fairness and inclusion, whether it's algorithmic or things that are coming because the creators are themselves, humans, and they have their own mental models and beliefs that reflect in what we do. So all are going to come to play. And so we have to, intentionally think about it, as a part of our computer sciences, computational thinking, and which is slowly happening, but it has to happen more. And this is the point that even Megan Smith touched upon. So the more we are creating and touching various parts of the world and people, the more sort of the other sort of aspects of it associated with it. It comes with a responsibility, right? And back to the people who create it. So that's why that the credo of many places like Google is to set that up as a part of their mission and principle. It's a hard problem. It's not an easy one, but I think it's something that we do. But I do believe that the promise of these technologies, like in supporting scientific discovery, supporting new ways of caring for health and well-being of people, is immense than some of the potential sort of stumbling blocks we will come across, which we have to attend to. And so hopefully maybe these discussions will happen through the projects and other things in this workshop. Thank you for asking that question. So any other final questions or thoughts people want to share before we hand it over to the next part of the program? So I'm super excited, to have you all for the semester. This is really a amazing opportunity. And again, thank exploreCSR and the Google program, and the various mentors, both USC PhD students and our mentors from Google that will be coming along to launch this. And I hope that you will also become mentors. Right? There are going to be things that we are imagining for reaching out to high school, middle school students to sort of inspire them, because a lot of times we learn from people who have been through, their journey, and that, helps us contextualize and role model, and so this is very useful and, part of the learning experience. So thank you, and so I'm super excited. So I hand it over to Kathy.
Make sure I'm unmuted. Before we jump into having our mentors introduce themselves, we just kind of want to share with you guys all some of the stats of our community. It's called our class. Let me just share my screen very quickly. So this is all the majors and all the years from you guys. Like we have participants across from, Viterbi to Enneberg to just all these different majors that were really great. We're really glad to bring this impact on. And also these are the years we have pretty even, like, freshman through junior and some senior, but definitely we want you guys to make the best out of, this program, no matter, what year you are, and carry it forward. And let me just introduce our first mentor today, Krishna. Okay, yeah, you have the floor.
Hey everyone, it's so nice to see you all. And as you can see on the slide, students from various departments and various years in your undergrad. So I'm really looking forward to working with you all. I'm Krishna Samandapalli. I'm a sixth year PhD candidate in electrical engineering, advised by Shri. I mostly work on multimedia content understanding, and since my first year in engineering and PhD, I mostly work with how to understand how people and characters are portrayed in movies, and how that reflects in representation and other aspects. I'll hand over to the other mentors, but just one thing I'll note before I hand it over is, although my major is engineering, I always thought, and I believe, talking to people in other fields like communication or journalism really helps us understand our own problem. Before solutions, we should understand what the problem is. So with that, hand it over to the other mentors. Amrita, do you want to introduce yourself?
Hi guys, I'm Amrita. I'm a fifth-year PhD student working with SAIL. Shri is my advisor. I have a background working with wearable sensors and healthcare. I'm also really interested in working on media intelligence and representation of women, how interactions happen when women are involved, and a lot of other things with CCMI also works for. And yeah, I'm really excited about this workshop and getting to know all of you. Feel free to reach out anytime. Rajat, do you want to go next?
Sure. Hi everyone, I'm Rajat Hebbard. I'm a third-year PhD student in electrical engineering at SAIL, also advised by Professor Sri. My research focus is mainly around developing robust speech and audio processing technology using machine learning, specifically in challenging acoustic domains such as multimedia, which is something we address during this workshop series, and also several other real-world audio domains. One of the projects I would like to briefly discuss related to this is our collaboration with one of the UN agencies, ITU. So going into the research aspect of this, I didn't really think of the application, but it's a wonderful thing when you collaborate with professors, research departments, and other institutions. You can use applications such as this. So I developed in collaboration with colleagues at SAIL, like state-of-the-art speech activity detection and gender identification modules. And through a wonderful collaboration with one of the UN agencies, ITU, we were able to use these tools to sort of raise awareness across UN agencies of how much, in just simple terms, how much participation is occurring across genders. That is, how much speaking time is attributed to males versus females, and just raise awareness on how vocal participation may differ from actual presence in meetings. So yeah, that was just one quick application I wanted to share. Super excited to work with, to know all of you guys and work with you during the course of these workshops. And yeah, I'll hand it over to Dylan.
Hi guys, I'm Dylan Knox. I'm a third-year PhD student in electrical engineering, also under Shri. And my primary focus is in audio signal processing I'm focusing a lot right now on music specifically, music information retrieval, and doing a lot of how music characterizes aspects of media, including in film. And that's kind of one of the things that I think is really interesting right now, is specifically in machine learning. There are a lot of opportunities of bringing in a lot of different disciplines and a lot of interdisciplinary research, and a lot of areas that I think are very, very diverse. In our lab, for instance, we'll go from anything from exploring, media content to, say, like health intervention and human behavior type interactions. And all those can be combined and explored, from computer scientists to, some less STEM-based disciplines as well. So I think it's really interesting, and a lot of different backgrounds can contribute to this kind of research. So I think we have a pretty diverse group of students, and I think all your experiences can definitely contribute to a project kind of under this one umbrella. So I think it's really exciting, and I'm excited to work with you all this semester. And with that, I'll hand it off to Digblade to bring it home.
Thanks, Dylan. Hi, everyone. Welcome to the workshop. I'm Digbale, a third-year PhD student in SAIL Lab. I'm advised by Professor Sri. So my primary focus is mostly video processing. I work in developing machine learning models for understanding media sources like advertisement and movies. I also look at video processing for healthcare applications like facial paralysis patients analysis, and also for autism spectrum analysis. So one project that I'm really interested is understanding persons in media, like, as I mentioned, movies and ads, and how they're represented and how the background influences the way they're being represented in different sources. So super excited to work with you guys, and just feel free to ping me if you have any doubts or anything. Happy to work with you throughout the workshop. So I hand it over to Ramita.
Thanks, Digbale. Hey everyone, I'm Ramita. I'm a third-year PhD student at SAIL. I'm also advised by Professor Sri Narayanan. So my research focus is majorly audio and speech signal processing, with applications majorly in healthcare and media analytics. So to bring up, like, we usually focus in developing computational methodologies that can actually aid clinicians to for monitoring and diagnosing disorders like autism spectrum disorder. And also I am really interested in exploring conversational dynamics from data like UN meetings that Rajat was referring to. So I'm really excited to meet you all, and I look forward to this workshop.
I think, Burke, do you want to introduce yourself?
Yeah, sure.
Thanks, Ramita.
Yeah, thanks, Ramita. I'm Bark. I'm a first-year student, PhD student here, again under advisement of Professor Sri. I don't have a specific focus at the moment. I'm still exploring a broad set of projects that are within the interest of SAIL. But to name a project, I'm interested in detecting personal attributes from images, such as age, gender, or race. Super stoked to see you all and work with you all. Thank you.
So these will be your mentors for for this next several weeks, and I think from the email or communication that we share with you guys is next week, Wednesday, we will have a happy hour which is that, like you time. Like today, you've been hearing a lot from us, from, our mentor and our awesome keynote speaker and all the speaker. But next week, we want to hear from you guys. And so we have a little assignment for you guys that, so between now and then, the next week, you're supposed to know someone. And then you will introduce them during the happy hour next week. And you can use the Slack the Slack channel we created and the PowerPoint to find someone from a different major. And let's say if, Krishna messaged me, say, hey, I want to introduce you, but Ramita already talked to me, then 3 of us can work, in a circle where like Krishna will introduce Ramita will introduce me, and I will introduce Krishna. So we want you guys to be able to form, like a group or a community organically this way. And so next week we hope like, you would have already met, make some new friends from the group. And for our icebreaker, just think of something interesting or, like cool question to ask, so we can like learn more about each other. And I don't know if the mentor has anything else to add.
Thanks, Kathy. I think we'll send them more info on the icebreaker on the Slack channel. We are still iterating on how to like effectively do a Zoom icebreaker.
Okay.
But like Kathy said, I think the more important thing is, I think if this were in person, you would have multiple opportunities to interact. So I would really urge you guys to like try and get to know each other, at least each other's names and faces. Try and reach out to each other, try to find something cool about the other person, and so that it's easier for you going through the workshop to have a sense of community.
Thank you, Amrita. May I ask a question, or can you give a very quick, 30-second preview of what is coming up in the following weeks? We briefly touched upon those, but
yeah, I'll take that. Yeah, I realize a lot of the stuff we talked today is very abstract. Some of it, you heard a lot of terms, deep learning, machine learning, all of that. Don't worry about it. We'll walk you through all of that. And the icebreaker, so the icebreaker will be half and half, some half play and half work. So the work part of it will just lay out what the rest of the workshops looks like, what are the different workshops focusing on, and what is expected of you. For now, the main thing for now is engage, interact, and ask questions. And you're all here, which is a great start. Use the Slack channel to 100%. Ask questions there, and there are the slides where you put a picture of you and you introduce who you are. Make sure you go through it, get to know others. I'll try to give a 10-second pitch of what you'll see in the rest of the workshops, but we'll talk more specifics in the icebreaker. By the end of this workshop series, you will have some experience in basic programming. And more important than programming, I hope you'll pick up 2 skills. One, asking questions, problematizing things. The first thing to do cool things is to ask the right questions. And then we'll also get you to do a group project, and get to a hackathon where you'll be presenting some interesting stuff. So I'll be related to media stuff, media understanding, and multimedia. Sorry, that's abstract. Let me give a solid example. Like say you're watching an ad. Can computers automatically try to understand how women are being portrayed in ads? Are they always in the driver's seat, or are they driving the car? Things like that. So hopefully we'll talk more about this in the coming workshops, but that's like a preview. So engage, interact, and ask questions, any questions. That's why we are here.
Thanks so much, Krishna, Murtha. Thank you, Kathy, for organizing today, and thanks to all our workshop attendees. I really hope that you make full use of all the sort of various possibilities, learning, about computational media intelligence, basics of, some of the computing techniques, getting to know each other. I think, community building, one of the things Megan mentioned, right? I know that's difficult for us, with Zoom and so on, right? Yet another Zoom meeting, but hopefully this will be fun, engaging, and we get to listen to other mentors from industry. So this will sort of open up new possibilities for all of us. And thank you to all the mentors. Look forward to an exciting, semester and workshop. Thanks again, everyone. Till next time. Use the Slack channel, ask questions, reach out to us, reach out to me, reach out to anyone. So super exciting. Thank you.
Thank you, Shri.
Thanks, Shri.
Good night, everyone.
Yeah, thank you all. We'll see you next week.
Thank you.
Hi, guys.
Bye, everyone.
Nice.
Bye, guys.
Great night,
Bye.
guys.
Nice to meet you guys.
Bye.